All right, this is part of the constructed response, so you are going to want to pay attention to this one. Algebraically solve each system of equations and name the method you used. Graphically check your answer. All right, so it looks like, oops, sorry guys, it looks like A is set up perfectly to do some elimination. 7x minus 2y equals 3. 2x plus 3y equals 33. I've noticed, watch my videos, I keep smacking my lips. I don't mean to do that. So I'm going to try to stop. So if I multiply this by 3 and this one by 2, this should work out. That gives me on the top equation 21x minus 6y equals 6. And on the bottom equation, 4x plus 6y, so there's my opposites right there, is equal to 66. And we combine these. We get 25x is equal to 72. 72. Divide both sides by 25, and x is equal to, whoops, 72, 72 divided by 25, 2.88. Okay, and we can take that and put it back into one of the original equations. So how about 2 times 2.88, we solved for x, plus 3y equals 33. So 2 times 2.88 is 5.76, and 33 minus 5.76 is 27.24. So what we have is 3y equals 27.24 divided by 3, 9.08. So y is 9.08. X is 2.88. Graphically check your answer. I'm not going to graphically check this one, but you know what I am going to do that's going to be a good reminder for you guys is use the matrix to check this. Because if I checked it graphically, I'd have to solve both for y, and that seems like a little more work to me than necessary. So I'm going to go into the matrix. Whoops. I'm going to go into the matrix once. I'm going to edit. We have 2 by 3. That's perfect. And it's 7, negative 2, 3, 7, enter, negative 2, enter, 3, enter. And then the second equation, the bottom equation is 2x, but I just put the 2, 3y, but I just put the 3, and then 33. And then I have to quit. And then I go back into the matrix. Then I go to math. And then I'm going to go down to RREF, whoops, which is B. And then one more time into the matrix, and I'm just going to choose, now I'm just going to choose A is the one I think I used. And I get 3 and 9. So where did I make a little mistake? I made it in, oh, here. Have you guys been yelling at the screen this whole time? 3 times 3 is 9. 66 plus 9 is not 72. It is 75. Oh, that makes this a lot easier, doesn't it? And if that's 75, then x is just 3. Sorry, you guys, I've been making these videos for too long. So that's 75. X equals 3. So 2 times 3 is 6 plus 3y equals 33. Subtract 6 from both sides. I get 27. And y equals 9. And aren't you glad that you checked your answer? And here it is. 1, where the x's is, 1x is 3, and 1y is 9. So 3 and 9. Glad I checked my answers. And then the second one looks like it is going to be easier, let's see, to graph it, because 1 is already solved for y. So if we do this algebraically, since I already have y solved here, I'm going to go ahead and put that in for y. So we have 3x minus 1/2 times 4x plus 2. Instead of y, I just put 4x plus 2 equals 1. And I'm just going to solve this 3x minus, I need to distribute that 1/2. So half of 4 is 2x. And then minus again, half of 2 is 1 equals 1. So 3x minus 2x is just x minus 1 equals 1. Add 1 to both sides, x equals 2. And then let's put that back in, y equals 4 times 2 plus 2. So 8, 9, 10, so y is 10. If we check it graphically, in one of the y equals, it's already working for us. We have y equals 4x plus 2. In the other one, I just need to solve this one really quickly for y. So I'm going to subtract 3 x's from both sides. So then I have negative 1/2. Y equals 1 minus 3x. Multiply both sides by negative 2 over 1, and that'll cancel this out. And if we make it negative, it'll make it positive. And then multiply the other side also by negative 2, and we get y equals negative 2 times that whole other side, which was 1 minus 3x. Now we can enter these into the y equals, and where they cross is where the answer is going to be. So 4x plus 2 in the first one, and negative 2 parenthesis 1 minus 3x parenthesis. I'm just going to start out Zoom 6 standard 1, see how it goes from there. So it looks like about up here, they're going to intersect. So I'm going to do second trace. I want 5 because it says where's the intersection. And then I'm going to hit enter until it says intersection end 2, comma 10, which is exactly what I got. So word. And this last one looks a bit more complicated, but I think the one on the test is a bit more complicated. So let's factor the bottom one, solving the systems of equations. So actually, I'm not going to factor this because look, I can solve it just like this. Let's combine them because this cancels out. So I get 4x squared equals 20. X squared, if I divide it by 4, equals 5. So x equals, if I take the square root of both sides, positive and negative, square root 5. And I can put that back into just one of them, right? If I put it into just one of them, it should work. So x squared minus y squared equals 4. And I make x positive and negative square root 5. And it doesn't matter if it's positive or negative because I'm squaring it. So whatever I'm squaring, positive root 5 or negative root 5, I just get 5 minus y squared equals 4. Negative y squared equals, if I subtract 5 from both sides, negative 1. So y squared equals positive 1, and y is the square root of 1, so y is equal to positive and a negative. You don't need to put the square root of 1, we'll just put positive and negative 1. So can we use the calculator to solve this? Yes, but we can't use the matrix. We are going to have to solve this for y. So what does that look like? Let's see. We have on the first equation y squared equals 16 minus 3x squared. So y equals the square roots, 16 minus 3x squared. And on the bottom one, we have negative y squared equals 4 minus x squared. But we're going to divide it by negative to get rid of this negative. So what that does is it just changes each of these. It just gives us negative 4 plus x squared then take the square root. So we have y equals the square root of negative 4 plus x squared. So these are the two equations we want to put in the calculator. I'm going to pause and do that. You guys, this is so adorable. So here I put in my equations, and I'm going to hit graph. And it makes this like little person with its hands in the air or setting sun. Anyway, it's a cute little picture. And I'm going to go ahead and trace and try to get close to where one of the intersections is. Then I'm going to do second calc. Then I'm going to do intersect. And I have to hit enter until, whoops, I did the derivative on accident. Second calc, intersect. And I get y is positive 1 and x is negative 2.23, which I bet is negative square root 5. And then let's go over to my other answer, or to the other intersection point over here, or at least closer over here, and find that one. Something's wrong here. Let's look at the table. Might not exist on that side. Let's see. So we found out that when x was, oh, it doesn't exist past that. Why? Stop going down. Go up. Cool, so what did we decide? So it looks like we found some extraneous answers, right? I'm sorry, I'm moving too fast here. Looks like we found some extraneous answers. So not every answer that we found algebraically are we going to be able to see in the graph, because it just doesn't exist, right? Look at all these errors because of the square root. So we do have zeros at 2 and 2, and we did have one intersection point, which was at where y was positive 1 and x was the square root of 5, but you can't see it on our table because we're just counting by these numbers over here. So it looks like there's actually only one answer, and that answer was, and that's why it probably wants you to check it graphically. So we have some extraneous answers. So algebraically, we could get these answers. Okay, but they are, some of the answers are actually complex numbers or imaginary numbers that you can't find on the graph, which is fine. But there's only one concrete answer that we can find on the graph, and that was when x was negative square root 5 and y was positive 1. Okay, so just highlight that one. We know that that's the one we got graphically, but the ones that we got algebraically, these are perfectly all right answers to have. They are just not all, some of them are extraneous and not represented on the graph, or they're complex. Okay, that's okay. That's why they have us graph it. All right, you guys, last video. I hope you have a good night, and I will see you tomorrow.